The purpose of this video is to talk about why you saw the results you saw and what that kind of demonstrates to us scientifically in the Microrocket lab. So here is all the data from everybody in our class. There might be a few more people added on here, but that's okay for the purposes of this demonstration. For what we got right now on Friday afternoon, this is a graph of 1 part hydrogen, 5 oxygen, all the way down to 5 parts hydrogen, 1 oxygen. And over here, notice that I haven't added anything on the axes here in terms of labels or for a title for the graph. That's something you'll do in your lab report. But this is the meters, the distance it flew in meters. So as you can see, definitely the middle 3 were the best. The 2 on the ends didn't give us the best. It's a little bit difficult to just tell from looking at those 3 graphs. If you scroll down, I did the graph of the averages. Those are the averages right here. And then the graphing of the averages, you can see that 4 hydrogens, 2 oxygens does give us the best combustion reaction for this rocket. On the next part of the video, I'm going to talk about why that is on a kind of molecular basis and as far as balancing chemical equations. So mesh 1, I'm going to show you really quick why we saw that 4:2 ratio. Sorry if you can't see me, this is a tall person disadvantage. So we saw a ratio of 4 parts hydrogen, 2 parts oxygen gave us the best combination. If you simplify that, that gives you 2 hydrogens for every 1 oxygen. If you remember from the front page, I'm hoping that you filled that out, the reaction that's actually happening here is H2 gas plus O2 gas gives you H2O. The problem here is that 2 hydrogens plus 2 oxygens can't give you 2 hydrogens and 1 oxygen. There's a leftover oxygen. If you see it, there's 2 and 2, 2 and 1. So what you have to do is something called balancing the chemical equation. What that means is putting some coefficients in front. If you remember from the Build a Molecule lab, if I put a 2 out front here, what that means is I've got 2 waters. I've got an HOH and another HOH. And then over here, I've got an HH and an OO. Well, the fact that I put the 2 out front means I have 2 of these molecules. That's a total of 1, 2, 3, 4 hydrogens and a total of 1, 2 oxygens. So to get this all balanced, I need to put a 2 in front of our hydrogen molecule, giving us another H-H. So now this is balanced. We've got 2 hydrogen molecules for every, there's really a 1 in front of here, a 1 oxygen molecule to give us, why am I doing that? To give us 2 water molecules. So that is a balanced chemical equation, what we just did there. And the reason that the combustion reaction, or the reason the rocket launched best with 4 parts hydrogen, 2 parts oxygen is this is the closest to not having any leftovers kind of on either side. Because if you've got 2 to 1, you don't have any extra hydrogen that doesn't get burned up or any extra oxygen that was wanting to burn up hydrogen. It's kind of like if you measured out all of your ingredients before making a recipe in the kitchen, baking cookies, if you measured it all out perfectly, you wouldn't have any leftovers, you wouldn't have wasted anything essentially. So when you use this combo in your rocket, you weren't wasting any gases. I hope that helps make some sense of that for you, and have a great Monday.